Alright, okay, as I promised you that for this part, it will be another knowledge of finding, of showing that the two circle is intersecting with two distinct points. Okay, very simple. So, okay, let's use the knowledge of, let's say two circles is intersecting. Okay, I draw a diagram to tell you that, let's say this is the center one, okay, and the second center. So, the distance between the two point, right? The distance between the two center. So I label to the distance between the two center, okay, as C1, C2, right? The distance C1 and C2. So, and the sum of R1 and R2, the radius. So means that before the two circle is intersecting, right? Before the two circle is intersecting, the center, the first circle will definitely have a radius, right? Will definitely have a radius, will have its own radius. Alright, will definitely have its own radius, right? So together with another circles, okay, another circles. So before intersecting, so means that we consider them separately. So this is center 2, right? So then the radius is R2, right? Definitely when they intersecting, right? When they intersecting, the two center, so means that the distance between the two center, right? Because they're intersecting, so means that the part of R2 is overlapped with the radius of first circle, right? So then we can say that definitely the distance between the two center will be less than the distance, the sum of the distance between the two circle. Okay, and you try to imagine that, right? So when these two are overlapping, okay, when they are overlapping, so means that the radius for the second circle and the radius for the first circle, right? You see, the part of the radius for the second circle is on the, we can say that it's actually can fall on the, so when they are intersecting, for example, so part of the radius, right? Part of the radius for the second circle is on the line of the radius, the first radius of the circle. So the total of the distance, right? The distance total up, these two, will definitely more than the distance between the two center, right? So as long as you can prove that the distance between the two circle is less than the sum of the radius between these two circles, and you already proved that these two circles is intersecting at two distinct points, right? Without finding the intersection point. But this method is a bit tedious, so I got to tell you that for the first circle, you can using the x squared plus y squared plus 2gx plus 2fy plus c equals to 0, right? So by comparing this, you have center, negative g, negative f, and c to be, the radius, the formula for radius will be square root of g squared plus f squared minus with c. Okay, so by applying this formula, I can find the center and for this first circle and second circle easily. All right, I'm not going to show you how to doing this. So I just compare 2g with 0, 2f with negative 2, and c with negative 4. And I find the value of gf and plug in all the value here. I can find, okay, for circle, right? I tell you the answer. For the first circle, the center will be 0, 1. Okay, the center will be 0, 1, and the radius that I found will be square root of 5. All right, square root of 5. Okay, let's look at the center for the second circle, right? Right. Through the result that I find by using the general equation, so I can find that 2g, all right, 2g I compare with the 0 here, and 2f with the negative 2, I can get the value of f, right? And substitute into here, I get the center. So this is a basic, you can refer to the previous video. So, and the second radius I found to be 5 over 2 square root of 2. 5 over 2 square root of 2. Okay, so now what I'm going to do now will be, I want to show that the distance between the two circles, alright, the distance between the center of the two circles, C1 and C2. Okay, C1 and C2. So I can just calculate as a square root of 1 over 2 minus 0, 1 over 2 minus, minus with 0 square, plus with negative 1 over 2, negative 1 over 2 minus 1 square, right? And this is the formula for distance, right? x1 minus x2 square, y1 minus y2 square. So I was getting 104. For this I was getting 104, right? 104, and for this I was getting negative 1 over 2. Negative 1 over 2 with negative 1, I have negative 3 over 2, right? So which gives me 9 over 4, because you square, right? You square 9 over 4. So giving you 10 over 2, right? 9 plus 1, so you have 10. 4 and 4, so you are getting 4. So square root of 10 over with 2. So this is the distance between the two center, right? The distance between the two center. So alright, let's see. So the distance between C1 C2 is square root of 10 over 2, and the sum of the radius, right? The sum of the radius R1 plus R2, I'm taking square root of 5 plus with 5 over 2 square root of 2, and I check the value by using calculator and try to see. Alright, based on calculator, I change it to decimal form, which gives me 5.77, right? The value of this, of the sum of the two radius of the circle, right? And look at the value. So I change it into decimal. I was getting 1.58, right? 1.58. So it means that you see that the distance between the two center, alright, the distance between the two center is less than the sum of the radius, right? The sum of the radius. This shows that these two circles is actually intersecting, right? It's actually intersecting, because while they're intersecting, the distance between the two circles, the distance between the two circles, the distance between the two center, so will be lesser than the sum of the radius, the radius 1 and radius 2, right? Definitely, because part of the radius, the length of the radius 2 is on the radius number 1. So it means that the sum of these two, of course, definitely will be greater than the distance between the two center. So as long as you can verify that the distance by using this concept, you have shown that the two circles is actually intersect with two distinct points. Alright, this is for your knowledge, alright, for your extra knowledge. So in case if you face this type of question, they say asking you to using the center and the radius to verify. Alright, but the best method will be the previous video. Before I discuss this video, I identified by solving the simultaneous equation, and I getting two distinct points, or I using the method of b square minus 4ac. I show that it's less than 0, right? It's less than 0. It's more than 0. The discriminant, solving simultaneous equation, the quadratic will have two real roots. Means that the b square minus 4ac will give a positive value. Alright, that method will be recommended compared to this, because this is very time consuming. Alright, I think that's all for this video.